Have you ever imagined a liquid that could just like turn solid, like instantly?
It'd be like something straight out of science fiction, right?
Totally. And that's what we're looking into today. These things called Magnetorheological fluids.
Or MR fluids, as they're often called.
Yeah, MR fluids. So what's the deal with these things? What makes them so special?
Well, they have this pretty unique ability to change how they flow. We call that their viscosity, and it changes just by being near a magnet.
Okay, so like if we think about viscosity, like how easily something flows, that's the difference between like pouring water and pouring honey, right?
Exactly. Water flows easily low viscosity, but honey, it's thick, high viscosity. It resists flowing.
So these MR fluids can like go from water to honey, just like that?
Pretty much, yeah. It's a dramatic change. They can basically become solid. And that's what we're diving into today. 5 fascinating facts all about MR fluids.
All right, let's do it. Factoid number 1, Magnetorheological fluids. Viscosity shifter. So we talked about viscosity, right? How easily something flows. But remind me, why is it so important with MR fluids?
Well, imagine being able to control that flow on demand. You could make a fluid thicker or thinner instantly. That's the key to what makes these MR fluids so special.
It's not just that they get thicker, but that you can actually control it. That's pretty wild. So how does that even work? What's the secret behind all of this?
Factoid number 2, iron particles. The microscopic magicians, MR fluids are made up of these tiny iron particles, and they're suspended in a liquid, usually some type of oil.
Okay.
Now, when there's no magnet around these particles, they're just all jumbled up randomly. That's why the fluid can flow freely.
But then you bring a magnet close and boom, magic happens.
You got it. The magnetic field, it's like this invisible force, and it instantly makes all those iron particles lined up.
So they're not just floating around anymore. They're like all lining up in a row.
Exactly. They form these chains along the magnetic field lines. And because all these particles are linked up now, it creates a lot of internal friction.
Ah, so that's what makes the fluid so much thicker.
Right. The stronger the magnetic field, the more solid the fluid becomes.
That's incredible. So we have these tiny particles creating this huge change in the fluid. It's like you could solidify it with a switch.
That's a good way to put it, yeah. And this ability to like switch between states, that opens up so many possibilities.
Okay, I am definitely hooked. So where does this technology actually show up in the real world? It's got to be more than just some lab experiment. Right?
Oh, absolutely. Let's move on to factoid number 3, active suspensions, from bumpy rides to smooth sailing. Okay, have you ever been in a car where the shock absorbers were either way too stiff or way too loose?
Ooh, yeah. You're either bouncing all over the place or bottoming out every time you hit a bump. Not fun.
Exactly. So imagine if your car's suspension could adapt to the road, instantly adjusting to smooth out every single bump. That's what MR fluids can do.
Wait, really?
Yeah, by controlling the magnetic field around the fluid in the shock absorber, you can change its viscosity, make it stiffer or softer whenever you need it.
So it's like a smart suspension system. It's always adjusting to give you the smoothest ride possible, no matter how bad the road is.
You got it. And that's just one example. They're also using things like vibration control for buildings and bridges.
Wow, okay, so this technology could literally make our world a smoother, more comfortable place. I like it. But I have a feeling we're just getting started, right?
You're right about that. MR fluids go way beyond just smoothing out bumps in the road. We can even take it to the digital world.
Okay, I'm ready for factoid number 4. Hit me with it.
Factoid number 4, haptic feedback, feeling the future of touch. So think about those vibrations you feel on your phone screen when you type or play games.
Oh yeah, haptic feedback. It's like how my phone tries to make me feel like I'm clicking actual buttons. What does that have to do with MR fluids?
Well, imagine being able to feel actual textures through your screen or feel resistance when you're interacting with things virtually. MR fluids can make haptic feedback way more nuanced and precise.
Hold on, so you're saying with MR fluids, we could like feel the texture of a sweater we're looking at online, or feel the weight of something we're holding in a virtual reality game?
Exactly, and this is just the beginning. The potential for MR fluids in haptic technology is huge.
Okay, now I'm really seeing what this stuff can do, and it sounds like we're not even close to done yet. So what else can these magic fluids do?
Well, let's move on to factoid number 5, and this one takes us into the world of robots.
Bring on the robots.
All right, factoid number 5, robotics, precision grip and movement. One of the biggest challenges with robots is making them interact with the world as delicately as humans can.
Yeah, robots are known for being kind of clunky. So where do MR fluids come in?
Well, imagine robotic arms with joints that can be both incredibly strong and super sensitive at the same time, or grippers that can pick up a fragile egg without breaking it and then turn around and hold a heavy tool with no problem.
So robots that can do a lot more, from delicate surgery to heavy manufacturing. That's a game changer.
You got it. MR fluids make it possible to control the stiffness and movement of robotic parts with incredible precision. By changing the magnetic field, you can instantly adjust the viscosity of the fluid inside a robotic joint or gripper, giving it the exact amount of force and sensitivity it needs for whatever it's doing.
Okay, I'm officially mind blown. This is next level stuff. But I bet we've only scratched the surface of what MR fluids can do.
You're absolutely right, and that's what makes it all so exciting. There's so much more to discover and explore. Who knows what kind of applications we'll come up with next.
All right, well, we've covered some incredible ground here, from viscosity shifters to robots and everything in between. So before we jump into even more mind-blowing stuff, why don't we?
Take a quick break. We'll be back in a flash. Welcome back. We were just talking about how MR fluids are revolutionizing robotics, giving them the dexterity and precision we never thought possible.
Yeah, it really is mind-blowing to think about all the things we could do with that. But I do have a question. Are there like any downsides to this technology? It seems almost too good to be true.
Well, like any new technology, MR fluids do have some limitations. One of the big ones is cost. The materials and the whole process of making these fluids can be pretty expensive.
So you're saying it's going to be a while before we all have cars with MR fluid suspension?
Probably, yeah. It's just not cost-effective for a lot of applications right now.
Okay, makes sense. But besides the costs, are there any other challenges?
Yeah, there are some technical hurdles too, like the response time of the fluids, how fast they change viscosity when you apply a magnetic field.
So it's not really instant, like flipping a switch.
It's pretty darn fast, usually just a few milliseconds, but for some things like super high-speed robotics or manufacturing, even milliseconds can make a difference.
I see. And what about using these fluids on a large scale? I imagine that's tricky too.
Definitely. Scaling up production to meet the demand of different industries is a big challenge. It's not as simple as just mixing some iron with oil. You need to have really tight control over the size and how the particles are spread out.
Yeah, so it's not a one-size-fits-all kind of thing.
Exactly, and researchers are constantly working on new ways to make MR fluids better for all sorts of different uses.
It's fascinating to think about all the work that's going on behind the scenes to make this technology work. Oh, and speaking of pushing the boundaries of what's possible, I read about some researchers who are trying to use MR fluids to make artificial muscles.
Yeah, that's some really cool research. They're using MR fluids to build these actuators that move up like real muscles.
So we're talking about prosthetics that are more realistic and responsive.
Exactly. Imagine prosthetic limbs that move with incredible fluidity and precision, all thanks to MR fluids.
Wow, that's amazing. What about other medical applications? Could MR fluids be used for things like surgery?
There are definitely some possibilities there. For example, MR fluids could be used to create really tiny surgical tools that can move through the body with a lot more control.
So instead of big incisions, we could have tiny robots doing surgery. That sounds pretty sci-fi.
It does, but it's not that far-fetched. And there's even research into using MR fluids for delivering drugs to specific parts of the body.
Wow, so we could have these tiny capsules filled with medicine that are guided through the bloodstream with magnets. That's incredible.
Right. It seems like the possibilities really are endless.
I'm totally with you there. But with all the amazing things MR fluids can do, I'm curious, what are some of the things that are holding this technology back?
That's a great question. We talked about the cost and the difficulty of producing them on a large scale.
Right.
But there are some other things too, like durability. MR fluids can wear down over time, especially if they're used in tough conditions, like high temperatures.
So it's not enough to just make them, you also have to make sure they can handle the real world.
Exactly. And then there's the safety aspect. MR fluids themselves are generally safe, but the magnetic fields you need to control them could mess with other electronics or even have some health effects if we're not careful.
That makes sense. It's a good reminder that every cool new technology comes with its own set of challenges.
Absolutely. But even with those challenges, the future for MR fluids is super exciting. The potential benefits in robotics medicine and manufacturing are just too big to ignore.
I can't wait to see what comes next.
Me too. It's a really exciting field to be following right now.
It's incredible to think about all the things we've talked about today with Magnetorheological fluids, revolutionizing car suspension, lifelike prosthetic limbs. It's amazing. And it all starts with something that sounds so complex, but ends up with real-world applications.
It really shows you the power of science and how creative people can be. We tend to think of cutting-edge science as something kind of out there, but MR fluids show how these discoveries can actually change our lives in big ways.
It makes you wonder what other cool sci-fi tech is just waiting to be discovered, right?
Absolutely, and it just goes to show how important it is to keep investing in research and pushing the boundaries of what we think is possible.
And speaking of pushing boundaries, I was thinking about all the things we haven't even talked about yet. Like, could MR fluids be used to make better telescopes? like to compensate for the distortion from the atmosphere and get clearer images of space.
That's a really interesting idea. I haven't seen any research on that specifically, but it's definitely possible. The way MR fluids change their optical properties when you apply a magnetic field could be used to make flexible mirrors that adjust in real time to correct for that atmospheric distortion.
Whoa, that's wild. We could use these fluids to literally see the universe better.
It really shows you how versatile MR fluids are and how they can be used to connect different areas of science.
And it makes me wonder what other fields could benefit from this technology. What about environmental monitoring or disaster response? Could MR fluids be used for that?
The possibilities are endless. Imagine sensors that can change their sensitivity to detect tiny changes in pressure or temperature, or actuators that could change shape to move through difficult terrain like a collapsed building after an earthquake.
It feels like we've only just scratched the surface of what MR fluids can do.
Definitely. And as scientists keep experimenting and coming up with new ideas, I'm sure we'll see even more amazing applications in the future.
Well, this has been a truly fascinating look into the world of magnetoheological fluids. A huge thank you to our expert for being here today and sharing your knowledge with us.
It was my pleasure.
And to all our listeners, thanks for joining us on this journey of discovery. Keep those minds curious, and we'll catch you on our next deep dive into the amazing world of science and technology.